that we will do. Each class will be accompanied with a recording, so we will have recordings for each class. And that is just because I think it's helpful that you revisit the recordings and just go through those parts that are worthwhile revisiting, because you may want to go a little bit deeper in understanding the topic. So for today's class, it's one Excel spreadsheet that contains basically two different variables, or three different variables, also naming the patient ID or the subject ID. We have a PowerPoint presentation, which is today's lecture, and we have also an R code. Those of you that can download it, please open it in R. Make sure to please load it in a way from R. So you open R Studio, and then you go in R Studio on File, Open File, and you find the respective file that you downloaded. I would like to again reiterate, it's gonna be a lot of lectures. It's gonna be 24 lectures with this class. 24 lectures with each class, at least 2, 3, up to 5, 6 files. So that's a lot of files. Please organize yourself that you have these files readily available and accessible for you. Yes, please. No, don't create it. I have posted it on Canvas. You can download it from module 2. So today is module 2, and we're starting off today with chapter 1 in the book. And please download the R file, put it in a respective folder that is labeled as module 2, and save it in there. And these modules, so what you see here, that's the structure I'm utilizing and that I have created, that basically corresponds with the modules in Canva on the syllabus. And I have posted an updated syllabus with updated deadlines. So then you know which chapter is which module, and you can just revisit this easily. So again, these are the 3 files. You have them on your Canvas to download. You will also see on Canvas, on the module for today, you're going to see practice quiz chapter 1. So these are the practice quizzes. I have revisited now all the test banks. The practice quizzes are approximately like somewhere in the realm of like 10 to 20% of the overall test bank. So all your quizzes, exams will be randomly sampled with a weight to the corresponding chapter from an overall larger test bank. And these practice quizzes are random small samples of the respective chapter. So you will have one of these practice quizzes to test your own knowledge for each of the chapters. So this is the first one accessible for you, and you can test your own knowledge and understanding after we finish the class today. Good. So today we're going to do an introduction to any questions of anything concerning the syllabus or what we discussed last time. Any concerns, questions? No, good. Okay, so today we're talking about an introduction to statistics, research, and design. So we talked about it already last time. So you have 2 are listed here, but altogether you have 3 different mainstays and main tasks of statistics. One is descriptive statistics, where you organize, summarize, and communicate data to the outside world. So you have data entries, you have raw records for, could be any individual in a population or in a sample population. It could be each measurement of a sample population. So if you have repeated measurements for individuals within a sample population. So you basically, in descriptive statistics, you find ways to summarize your data in a way that you can report an overall characteristic of your sample population. And this with the purpose that you can present this to an audience, to colleagues, to your bosses or whomever, or to your teachers. So you basically, you mean to find ways to present this data better and more organized and easily understandable, also labeled as aggregated, so summarized, aggregated, to communicate this to a broader audience. Inferential statistics is basically the next step to that. So where you basically use data from your samples to draw inferences, to basically get estimates of these underlying sample populations and to draw conclusions about research questions that you are asking your sample population. Let's say you are interested whether age plays a role in blood pressure estimates. And you measure the blood pressure in a population, you create a mean for each population, and then you create age, and you associate this in the line of age. So you draw inferences by comparing two samples as an example. And we'll talk about several examples during the course of today's lesson. So it's basically inferential statistics is to draw inferences or insights from sample population. Whatever that is, that could be the sample population over time, or it could be a comparison of different samples, or it could be dynamics and associations within one sample. We'll talk about the details, but that's basically what inferential statistics is. And thirdly, the third main task of statistics, which is not listed here, but I think it's important, is the design of research, the design of analytic approaches in a way and form that it can be utilized for statistics. And I think it's just important whenever research is being designed that somebody who is statistically inclined and who has a deeper understanding of statistics is on board of the design team and has a say and has a seat at the table to inform on what he or she thinks is appropriate in the design to pay attention for analytic purposes. So how often does data need to be collected? What's the sample size that is being needed? How many individuals do we need to study to really make an insight into the dynamic we're interested and answer this research question we're interested in? So statisticians need to have a say in that. So that's what I think is a third large important task of statistics. Yes.
What is the third one? What's the name?
The design of research design. So then we talked also about definitions. So we have populations. Population is a collection of a defined group that you're interested in. Can be the world population, can be the population in the US, can be the population of New York City, whatever you're interested in. The problem with population is that it's a large group of people. So a large group of people is very hard to study. So you can do a census, like is being done in the US, every 10 years, which costs a tremendous amount of money and creates a lot of work, and requires a lot of labor resources. So one way to get around that, one way to still be able to answer research questions that you have on the overall population is to create samples of your population. So we will have in chapter 4, we're talking about, no, chapter 5, we're talking about sampling and probabilities. And when it comes to sampling, that's the art of essentially have random samples. Because essentially what you want to have a sample that is representative of your population. That means your sample needs to, as a collective, have the same characteristics as the population as a collective. If you are interested in the association between blood pressure and age, there's not much purpose to study a population from a college campus where everybody is younger than 30, right? Makes sense. So you need a representative sample. And that's the art of sampling. And that's unfortunately a huge problem in research. So it's a proportion, it's a portion, it's a smaller subset of the overall population. And what you essentially do with samples, you study samples in a shape and form, in a fashion that will allow you to draw inferences and to draw conclusions that will allow you to estimate the dynamics you will observe in a larger population. Let's say you study a blood pressure drug, you see a dynamic of lowering the blood pressure in the sample, you assume and you replicate that finding. So you have like your first study, then you have your second study, you have the third sample, third study. And each of these studies shows the same dynamics. It shows that this blood pressure drug really lowers blood pressure. Then you can safely assume if I'm doing this with any member of my population, it will show the same dynamic. That's the idea. Good. For making these inferences and for drawing these inferences, you need variables, you need data. And data is essentially the most important aspect of statistics, because this data will allow you to do statistical method, utilize statistical method to answer these questions that you have. And that's literally the basis of all statistics, is that you have data. Not only that you understand your data and you categorize your data in various different types of data, but that you also understand how is this data collected, what are the problems with the data, how does this data distribute, what are the lowest values, what are the highest values, everything about this data you need to understand. And this is where we're coming back to descriptive statistics, right? So you characterize your data. But firstly, let's understand what variables we have. We have two major groups of variables. We have discrete and continuous variables. So essentially, discrete variables again stratify into nominal and ordinal variables, whereas continuous variables that can take a full range of values can be either interval or ratio variables. So now you're going to ask yourself, what's the difference? And when it comes to discrete variables, so you basically discrete variables. Let's continue. Oh, yeah. Let's skip the Stroop test for now. Let's move on with the classification. So if you have discrete variables, you have nominal variables first. These are a category or a name. So when you, for example, you want to quantify the number of Twitter users in a country, the nominal variable will be country. So it's a name. It's a specific name that labels the category in which you're collecting data. If you have ordinal data, it's the ranking of data. That means if you, for example, want to quantify how many individuals, how happy are students in the class, and you develop a 5-grade scheme of 5 different levels, the individual can be can classify themselves, self-report their happiness. You can self-report from 1 to 5. And this is the important distinction. It's not the actual response that will be the ordinal variable. It's the actual variable on which you actually can answer. So this 1, 2, 3, 4, 5, these 5 different stages of happiness are the essential ordinal variable. So that's the ordinal variable. So when you count them, and like how many responded, I'm very happy, or how many responded, I'm not happy at all, that data is essentially continuous data. So it's important to keep in mind, and this will come in your direction, and that will be questions that you're facing on the exams. Distinguish between ordinal and continuous variables, understand which one is the ordinal. So the ordinal is the one that is actually ranked. So it's actually the scale of happiness, that's the ordinal variable. The actual rating, the actual counts for each rating, that's continuous data. So then we have 2 types of observations that are continuous. We have interval and ratio. Interval are basically numbers that are equally spaced. So that is virtually every data you could think of that does not have a meaningful zero. And that's the distinction to ratio. A ratio has a meaningful 0 point. So what does that mean? And this is the best examples to kind of show that. You have the example of cookies. So you have here the 4 different subgroups of variables. You have nominal variables. That is the name of the cookies, whether it's chocolate chip, oatmeal raisin, whatever cookie you want to list there. This is the nominal variable. The ordinal variable is the actual ranking of your favorite cookie. If you say on a scale from 1 to 10, how do I like these cookies, right? So this scale from 1 to 10, that's your ordinal variable. That's your rating for cookie taste. Then you have the interval variable, which is the actual temperature of each individual cookie that you have at your disposition. So you basically have 10 cookies in front of you, and you measure the temperature of each of these cookies, whether they're out of the freezer or whether they're out of the stove. The temperature is an interval variable of each respective cookie. And now the ratio, that is basically where you have the categorical variable of the name of the cookies and how many cookies are left for each individual cookie type. That is your ratio variable. And this is where the meaningful zero kicks in, because if you have 0 cookies, you have no cookies. You can't have negative cookies, except for when you take a cookie loan. But that is not an example. So you basically have a meaningful 0 that basically defines this as a ratio variable. So, and that's also the big, yeah, let's not go there. Let's go back to the Stroop test. So as an example, to quantify data and to characterize data and to define different types of data, Nolan and Heinzen basically has an example for a so-called Stroop test. So the Stroop test measures the time to say the color compared to the time it takes to say the word. What does that mean? Would somebody want to volunteer? It's just a simple example. Yeah, all right, great. So now you have, you're gonna see 4 words now. And yep, you see 4 words, and you basically say these 4 words as fast as possible.
White, red, green, red.
Okay, so now let's focus on the next slide. And now I would like you to say as fast as possible the color of the font, the color of the writing.
Green, blue, red.
So what you see, we didn't do a measurement. Thank you very much. We didn't do a measurement, right? But you saw it took her longer. And this is where the brain kind of plays a little bit tricks on you, because you have a certain association. You have the association of the color with what you're actually reading. And when you challenge your brain to essentially dissociate these 2 vectors, you end up having a harder time to actually identify these colors. It's interesting, right? And it's interesting, and not only is it interesting, it's also quite valuable when it comes to pathological processes in the brain, because somebody who has certain kind of deficiencies in their brain, which could be caused by a stroke, could be caused by genetic deficiencies, would essentially, in a pathological setting, take particularly long to be able to solve this. So this being said, there is value to essentially use this for diagnostic purposes. And so now I'm trying to get out of here. And this is what the Stroop test does. The Stroop test is basically, so you show that to somebody unprepared, and you measure the time that it takes to measure this in a congruent setting, and then in a second setting where it's incongruent. And this is, as soon as I get out of here, yeah. This is basically what the Excel spreadsheet shows. So we have here on the Excel spreadsheet, three different variables. We have here, and this comes from a publication data set. This is a publication data set from R. So we basically have 3 variables here. We have here an ID variable, and this is a typical way how you would present data of that kind. When you have assessment, you got to make sure that each individual record that you have, every data point, is associated with a unique identifier. And you will hear me say that quite a bit. You have unique identifiers, which basically represents one individual. And you see here quite a difference between congruent and incongruent. And this is just like we've just observed. This is just, it's a reflection of the brain kind of having a hard time dissociating these two vectors and focusing just on one without paying attention to the other. And that's how the brain works. And so now we have this data. And what I want to show you here is essentially how data can be analyzed. And this is just a quick taste, right? So we're going to do this in much more detail when we get to more advanced topics. So basically you can do, and all of you know, an average, and simple arithmetic average. A simple arithmetic average is nothing else but the sum of each individual entry divided by the number of entries. What that means in the end of the day is you're summing up all these times, and then you divide it through the number of participants. And that gives you an average. And this average is shown here. And Excel is actually a very nice function. It's the so-called average function. And this, the only thing that is required from you is to write an equal sign, which indicates that this will be a formula in the end of the day. Then you write the actual function, which is average. And then with parentheses, you basically indicate, okay, so now I'm giving you the data range. And B2 colon B25 indicates the range from B2, remember, first, always the column. Second, the number is essentially the row. So B2 is this column, and B25 is this row. So it will select all data points from B2 to B25 and calculates the average. In the same fashion, incongruent will do the same. And we're basically creating an average from C2 to C25. The difference here is the column. So you basically use a different column, but it's essentially the same data. What's nice in this context, if we had only created now, so we have an equal number of congruent and incongruent data points. No? Okay, so we have equal number of congruent and incongruent, and it's an average of B2 to B25. We remember from last time, if we just pull that formula, it will shift our observation range, right? So we can do the same thing here. We have here the average of congruent, and we want to copy this formula now to incongruent and only count the incongruent, or only to the average for the incongruent data. So we're going again on the cell, we're going to the right lower corner where the cursor changes, and we're pulling this to the right, and we'll basically get automatically the formula for incongruent. So this is a very useful function. That's why I'm keep on talking about this function. It's very, very useful in many settings. Good. Makes sense. So the data also makes sense. It's with congruent. It's actually shorter than it is with incongruent. So we will discuss in the following, we will discuss various use cases where you use this data. So this is the so-called central tendency. There's also, if you think of a distribution, and we'll talk about this in the next classes, if you have a certain distribution, you will do not only the mean, but you also want to understand how much does this data change around the mean. And this is when we were going to quantify the so-called variability with various matrices, with the most prominent one, the standard deviation. So this is congruent and incongruent, and then you can now operationalize your variable. So you can change it in various shapes and forms. So we talked about discrete and continuous. I hope it's obvious at this point in time that this is continuous data, right? So we have here an ordinal variable, which is the ID, and we do have continuous data, which is ratio data, because it has a meaning for 0. It has a meaning for 0 because 0 seconds is, it didn't take any time to say what you need to say. So it's impossible. It's a hypothetical example, but essentially it has a meaning for 0. So that's important to keep in mind. So it's ratio data that we collected for the congruent assessment and the incongruent assessment. And now the beauty of this is that you can take this data and you can quote unquote operationalize it, and you can discretize it. So in some certain scenarios, you will want to go from having continuous data to making this discrete data. And that's a little tricky because it requires some calculations, and it's usually in most cases it's impossible to go backwards, because you're taking away information from your individual entry, and you're assigning a certain value to this individual. And what you do is, so if we have here the ratio, we have here a ratio variable, you can go from a ratio variable to a discrete variable, which is seldom done, but occasionally you will need to do that. And particularly when it comes to inferential statistics, there are use cases where you will need to do that. So how do you do that? You're doing that by essentially transform it. If you, for example, you want to rank now each individual according to their rank, you can do this easily by, I'm showing you this function. So let's say you just want to bring congruent to a new spreadsheet. So here we copied now the congruent data in a new spreadsheet. We have now our individuals, 24 individuals, and now we're selecting these. One way to give a rank to each individual is just simply by sorting this data. And that's what I want to do now, because it's important that you know how to handle this data in Excel, and this will be important moving forward. So if you click on data and you go on sort, and that sounds super easy, but it has a little bit of caveats here in Excel. If you go on sort, you get here this menu that pops up. So you have here sort by, and you assign here a column which you want to use to sort it by. If you click on congruent, also please pay attention that my list has headers will automatically exclude the first row. So if this is selected, it will exclude the first row. If you deselect it, it will include the first row. It's important because if you start sorting the whole thing, it will sort your header row within your ranking within the greater data set. So if you select my list has headers, it excludes the header. Yes. Data and sort. It's right here. Can I see that?
Data sorting, just the ID.
Just ID and congruent, yeah. But if you go on sort by, just select here the column congruent.
Ascending or descending?
Yeah, that's my next point. So you do here an ascending, just do ascending. And let's click OK. And now it's sorted the entire data set, basically following the smallest entry first and the largest entry last. So now we can create a new variable, which we call rank. And we say, okay, so this was the fastest, that was the first one, second one, third one. And once we have done that, we just select 1, 2, 3. And we go on the right lower corner. And we're pulling this all the way down, and it will give us the ranking according to the speed of completing the task. If we're now selecting all this data, and we go back to draw.
How do you pull it all the way down?
With select, you basically click, you can also press shift. If you press shift and you go, so you can do this, you go on A1, and you go all the way down to C25, and you press shift while you're clicking on C25, it will select the whole thing. Yes. Yep. So we're doing, you type 1, 2, 3, and then there's the right lower corner where the cursor changes. And if you're pulling this down, you will see it automatically starts counting down. No, then you just grab the last one. You need to do 1, 2, 3, and grab all 3 of them. All 3, and then you just pull this down.
Explain again the continuous variable thing. I don't know.
Okay.
You had discrete and continuous.
You have discrete and continuous. Discrete can be either nominal or ordinal. Nominal is a name or a category label that essentially would here. So look at the cookie example. So you have nominal and ordinal. You have a name of the cookies. Then you have the ordinal, that's the ranking of favorite cookies. That can range from 1 to 7, and that ranking is the ordinal variable. And then you get interval, that's the temperature of cookies. So that can take on any value, also can be negative. So that's the most commonly used. And then you have the ratio that basically has a meaningful 0. So that's kind of a count of how many cookies are left, how many people in that category, how many Twitter users in Colombia. So this is the count in a way, right?
So what is this, discrete or continuous?
Discrete or continuous. So this is discrete, this is continuous. So it's the umbrella term. It's the umbrella term to distinguish between these two. Yeah? Okay. Yes. Excuse me? How to do sort? Yes, we can do that. Any other questions to discrete and continuous? It's an important concept. There will be quite a few questions on that on the exams. Okay, let's go back to sort. We remove this or. Okay, so we copy in a new spreadsheet. We copy ID and congruent. We're selecting now. We click on A1. We go all the way down to B25. We click on sort. We sort it by congruent. We have smallest to largest. We make sure that my list has headers is activated because that's how it will exclude the first row. Then we click OK. And then this data will be sorted. So this continuous variable, time used for completing the task in a congruent setting, will be sorted by the smallest first and the highest last. Then we go on rank. So then we're ranking them. We'll write 1, 2, 3. We're selecting these, and then we're just pulling this down. Gets us the ranking from 24 to 1. If we select it again and we go back to sort, and now we're sorting it by ID, it will preserve the structure, and it will now sort it back in the chronological sequence participants took the test. And it will preserve the ranks that we have assigned to each individual. And that's important to keep in mind. For the sort function in Excel, it will basically not change the order. It will associate one value with one individual, and that value will follow this individual. Super important to keep in mind. Yes. Yes, now they should be on.
So mine is already on.
Okay, that's fine. Then leave it on. No, leave it on. It's just important that you don't have the first, when you sort, that you don't have the first row activated. That's important. Yeah?
I have a question.
Yes.
When you sort it by, after I did a congruent, now I'm doing the ID.
Yeah.
Do I click the rank also? Do I highlight the rank?
No,
also?
yes, you select A1 to C25. You select all these 3 columns, and then you sort it again by ID. Yep. And then it will preserve the actual ranking, so you just rearrange it according to ID. So one value has attached now to an individual, and that's going to stick with that individual.
But the rank changed.
No, it didn't. It's still the same rank, because even if you look here, the fastest guy was still that one was 863. Exactly, it attaches to the individual or to the individual row. Good. Another thing that you can do, and this is quite elegant, if you want to know now, let's say you want to create a new discrete variable, which would be considered a nominal variable, which would be a special form of, yes, please.
So what we are doing, what we're doing right now is just trying to organize our variables.
Correct, yes.
So it's not, so you're just showing us that we can just keep adding variables and organize it accordingly.
Exactly. It's really, so what I mean to show you is the data that you will be using for all future steps. It's important that you understand how to handle, how to aggregate, how to approach data. Just that you have a little bit of sense. That's the idea behind this.
Format, if we paste one variable and another variable, first we have to sort those two, and then once we keep adding them.
Likely you will not have to sort. This is just for this example now with sorting, because I want you to see the sort function. I want you to see how to approach this data and the various way how to approach this data. And I just thought this is a good starting exercise. Yep. Yes.
Can you explain how you got to the ranking?
Yes. So the ranking is after you sorted, you start with 1, 2, 3. And you're just pulling this down by basically going here in the right lower corner. And then you're pulling it down, it will start automatically coding it. And then you just need to resort it. So the next nominal variable that we want to create now, we want to know now only individuals. We want to know, we want to assign a condition or a kind of a new variable to those individuals that had more, that took longer than 15 seconds. So if you want to have this distinction, you can do this. Took longer, okay, longer 15 seconds. You can do this with a function, and this is also a very important function, and it's maybe a little early for you to learn this function, but I think it's just important that you see how this can be handled. You can say if parentheses this congruent, so if B2 is greater than 15, then give it a 1, otherwise give it a 0. So what you get as a consequence to that, and you can just double click here on the right lower corner, it will continue this function all the way down. You will basically consequently get for entries that were greater than 15, you will get a 1 assigned. So what's the beauty of that? Because this is kind of a special form of a nominal variable. This is a so-called binary variable, where you only have 2 different conditions. It's either 0 or it's 1. And it's important to know how to deal with a variable like that, because it can be a very powerful variable to have. Because if you're being asked, okay, so I just want to know how many individuals had taken longer than 15 seconds for completing the assessment, you just need to do equal sign sum, S-U-M, D2 to D25, and you know that 9 individuals took longer than 15 seconds. So it's a summarization of a count, right? And we will do, in the next class, we will do frequency distributions. So there we will utilize such formula. Yes. Equal sum. So the if is, well, let me copy this over. So this is the equivalent. So this formula is if B2 is greater than 15, then assign a 1. So if B2 is greater than 1, assign a 1. If not, and that's after the comma, give it a 0.
How does it
Hmm?
that if not?
That's the one-on-one encoding. So this is a command that Excel takes, and there's a certain logic attached to that command, which is if this number is larger than this number, then assign it a 1, otherwise a 0.
then it's the same way. Kind of.
You could hypothetically do something like that. You could say, okay, so here's 15. If B2 is greater than this G2, not here. If B2 is greater than G2, and it would show you the same result. So it also, oops, no, it doesn't. Okay, then we need to lock it in that it doesn't change, otherwise it changes. I'm more about that next time. But basically, it would be the same result if it has to query that from a different cell. The beauty now is also that when you change now this cell, for example, it will also change the outcome. So you can dynamically approach this, and this is called what we in coding call soft coding. Soft coding, when it queries your criterion from a separate location, it's soft coded in the code. And this is better than hard coding it, where hard coding is basically implementing it in the formula where you're like, okay, so this is, if it's greater than 10, then take this. So this is soft coding if you have it in a separate cell. Good, but I don't want to go too deep into this, but this is kind of what you can do with your data, right? So 30 minutes left, let's carry on. So these are all the things that you can do. You can play around with the spreadsheet. I've posted the spreadsheet. I want to get now moving. So we get ratio data from the Stroop test. We talked about that. We can discretize continuous variables. So the same we can do with interval variables. So sometimes even interval variables are essentially discretized. Discrete variables, however, cannot go back to become continuous variables. There are some ways how you can do that by defining a midpoint of a range, but like, let's forget this for now. It's not really commonly done. It's a rarity. So, this thing. Okay, so that's the Stroop data. So now we have, with this data, we also have now a huge differentiation between those variables. So if you want to see a dynamic with your variables and you want to see some dynamics in your sample, in your assessments, you will have a dependent, independent, and a confounding variable. For the example of the Stroop test, the dependent variable, this is your actual measurement. So that's the time it took the individual to respond or to correctly complete the task of stating those 4 colors. So it depends on the independent variable, what the measurement of the dependent variable will be. So what in the context of the Stroop test is now the independent variable. That independent variable is congruent or incongruent. So the condition in which that dependent variable was collected will qualify here in this context as an independent variable. And now the third and last one, so it's the variable that you manipulate or categorize. So this is you categorizing the assessment according to the independent variable. And lastly, we have here the confounding variable. And that is essentially a variable that you need to get under control. You need to control your analysis for this variable because it kind of, or you randomize it away, because it basically gives you a distorted, biased, confounded kind of estimate of your dependent variable in the context of the independent variable. So that's the third variable that's floating around and gives you like a false outcome that you don't want to see. In the context of the Stroop test, that could, for example, be brain pathology. That's the confounding variable. If you're doing the same exercise in 10 individuals that did have a stroke, and in 15 variables and 15 individuals that did not have a stroke, these values are going to be different. The difference between congruent and incongruent is going to be different. So that's your confounding variable. That's the third invisible variable that you mean to evaluate and get out of the equation. Yes.
Incongruent.
It would be congruent or incongruent. So it's the level of the independent variable that allows to assign a certain value of the dependent variable to a respective level of the independent variable.
we don't change the congruent part because it's kind of just the words and the colors, right?
Well, yes. Now the independent variable here is really the nature or the level of the assessment. And this is by design, it's either congruent or incongruent. So it is done before the measurement is actually taken. So this was evaluated before. This is where statistics gets into design, but yeah. Yeah, no, this is research. You strategize, you plan, you design, then you collect the data, and then you throw all kinds of different methods at it to really make sense of your data. It's a very cool process. And so yeah. So when you have these measurements, two things are really important. You want reliable measurements and you want valid measurements. When you so reliable and valid measurements is basically it's two different things. It sounds intuitively like something that could be the same, but it's not. So reliable measure is consistent. That means if you measure your height today, it should hypothetically, if you didn't grew like 10 centimeters overnight, it should be the same tomorrow. That does not mean that your height that you're measuring is really the correct height. You could have measured it wrongly. You could have somebody measuring it was a tape they don't understand. It could be something that is not a valid measure. And that's important to distinguish those two. Because sometimes with some methods, you probably heard the term calibration of a measurement. So if you calibrate a measurement, you calibrate it to some characteristic, and then you measure it repeatedly and you get consistent measures. But that doesn't necessarily mean it's valid. So calibration actually means to calibrate it on a valid measure, on a valid level, and then the repeated measurements will produce reliable result in the light of a valid calibration, will allow for you to get repeated valid assessments. So it's important to keep that in mind. Reliable is the repeatability of things, whereas validity is that whatever you measure is really measuring what you mean to measure. And that's actually, believe it or not, is actually a major problem. It's not that easy, really not easy. Particularly when we talk later about surveys and these psychological surveys and these quizzes and I don't know, different methods, so-called psychological tools. It's not really clear if they're really measuring what they're measuring, and there are statistical methods to ascertain that this psychological tool that you're using, this survey that you're using, is really measuring what it's supposed to be measuring. So it's a lot of research that goes into these things. So in a perfect world, you want to have a measure that is reliable and valid, logically. Yeah, so various tests exist that are neither reliable nor valid. Example here, I don't know who of you knows maybe the Rorschach ink blot test. I usually always, no, come on. Okay. I usually always show a picture. There are usually good pictures here. There are usually good pictures. So if you look for a Rorschach ink blot test, yeah. You basically usually always get a good picture. So here Wikipedia never fails. So this is the Rorschach ink blot test, and this is being used in psychology. And I'm not sure, I'm not a psychologist, I can't really comment much on it. I'm not sure to what extent it's still being used. It means to diagnose personality and personality disorders by basically having particularly juvenile patients interpret the form and shape and what they're seeing in that picture. So now this is a heavily debated test, and it actually was put forward that this is neither reliable nor valid. And it's not really easy to standardize such a measure. So a measure should be reliable and valid. So it's really been debated whether it's either or. So that's an example of a test where this has been debated. However, any questions to reliability, validity, Rorschach ink blot test? If not, then we can carry on. So because what we will be doing in this class and what statistics is doing in the greater picture, you mean to kind of test hypotheses. A hypothesis is essentially an operationalized research question. If you want to understand whether blood pressure is different in diabetics compared to non-diabetics, you will develop a hypothesis where you say like, okay, so I think there's a difference between diabetics and non-diabetics. And this hypothesis you mean to test. With a research question, is blood pressure different between diabetics and non-diabetics? So you mean to test this. And this hypothesis, we will talk about null hypothesis, where you assume that there's no difference between two groups. And we will talk about research or alternative hypothesis, where we actually conclude that there's a difference between those two groups on a level of significance. And we will talk about this later on. So essentially in hypothesis testing, you always firstly develop a so-called null hypothesis, where you say, I am interested whether there's a difference in blood pressure between diabetics and non-diabetics. My null hypothesis is that there's no difference between diabetics and non-diabetics. Under my research hypothesis, I think there's a difference between diabetics and non-diabetics. In essence, what you do is you do with hypothesis testing when it comes to statistical methods, you mean to reject the null hypothesis. So you want to reject the null hypothesis and accept the alternative hypothesis, and you quantify the probability that rejecting the null hypothesis and assuming that there's a difference between diabetics and non-diabetics is wrong. That's what you essentially do. You quantify a probability of being wrong when you assume there's a difference. So that's hypothesis testing. So you're drawing conclusion if a difference in your dependent variable in the light of different levels of independent variable is supported by your data or not. That's hypothesis testing. And for that, you use statistical methods to test that. Any questions? I know this is where it's getting a little specific. I'm well aware. But to do this hypothesis testing, you need to operationalize variables. So this is basically procedures that allow for you to take this data that you have collected and bring it in a format that you can perform and formulate such hypotheses and then perform statistical tests to actually test whether the hypothesis is correct or not. So you create a framework in the context of your hypothesis in which you define a dependent variable and an independent variable. And this framework is very central. And this is important for you to follow along. And this is the example how to do that. So if, let's say you're interested in, research question is, are pet owners happier people? So now you have a dependent variable and you have an independent variable. Let's say the dependent variable is the level of happiness. So we have again a scale from 1 to 5, and you ask 100 people, are they happy? And then you ask the second variable, you say like, okay, do you have a dog? If they say yes, then you have two groups. You have the dog owners and you have the non-dog owners. So you have your dependent variable, level of happiness, and you have your independent variable, does the person have a dog or any pet? I think I'm a dog person, so I think dog makes the happiest, but I'm biased there. Good. Then second, you have level of cigarette smoking. So how many cigarettes do you smoke a day? You smoke 10, 20, 30? And how strong is your willpower? So you have a survey that assesses the willpower of an individual. The dependent variable is the individual a smoker or not? The independent variable is, what's his willpower? On a scale from 1 to 5. Are those that have a higher willpower a lower probability of being a smoker? That would be one way to look at this. So you basically define the dependent variable as the so-called outcome, and you have the independent variable as the predicting variable or the determining variable. Dependent variable, how caring are people? Independent variable, social media use. are those that use social media more caring people? Might be a longer debate, but yeah. So this would be the way to approach this and operationalize these variables. So this is the operationalization. And it's important that you kind of really think that through. You will certainly face questions to that extent, because I think this is a very important concept. So there are quite a lot of questions in the exams. And it's also for homework. So in various settings, you will be asked to operationalize such things. And once you understood the distinction between dependent variable and independent variable, it's considerably easy. Good. Any questions to that? If not, then let's move on. So we have now we're getting into the type of analysis. So this is just overarching, quickly talking about the types of variables. So we analysis. So we have most and foremost, and that's the most common way of analyzing data, that those are the so-called correlational study. A correlation basically is a correlation. That means that you have two variables that kind of associate with each other. So they correlate. That means that if you're healthier, you're more likely to use a wellness program. Or the other way around, if you use a wellness program, you're more likely to be healthy. You can't really establish causality on such analysis, but you see associations, and then you can make your mind about whether this is a causal relationship or not. So this is a little bit different from the more experimental kind of settings. In experimental settings, you have an experimental study, or you can have an observational study. If you have an observational study, you just follow the patient along, or you follow the subject along, and you collect data without doing anything with the individual. So you use some independent variable that you think is inherent to that individual, and you assign them to a group, but you just follow. If you have an experimental study, you're actually doing something with the subject. So you have somebody who you're going to, you have a so-called consent form. You go to that individual and say, like, I'm doing this study, would you like to participate? The subject says yes, he's part of your study. And then you basically use an experimental setting to employ a so-called intervention. And this intervention will then essentially allow you, and the intervention becomes now the independent variable, the different levels of the independent variable. So you have control group, which does not get an intervention, and you have the intervention group that gets an intervention. So let's say you assign whatever blood pressure medication to one group, the other group doesn't get the blood pressure medication. Intervention control. So basically it becomes the level of an independent variable. If you want to bring this to the highest level of scientific evidence, you would randomize this. And this is where you do a so-called randomized controlled study. That means that you recruit the individual, you go to the individual, you give a consent form, individual agrees to be part of your study. You do that with 100 people. Then you have 100 people, and you randomly assign 0 and 1, or randomly assign control or intervention for 50 people. 50 people are in the control, randomly assigned. 50 people are in the intervention group, randomly assigned. It's the leftover group. So by that, you have a distributed, equally distributed group. Why do you want to do that? Because you want to take out confounders. Because if you have somebody self-select into a group, and says like, I always had high blood pressure, and I'm 70 years old, and I really need this blood pressure medication, you're going to have a group of intervention patients that all are older, all have high blood pressure, purportedly, and all want that blood pressure medication. And so you want to distribute those evenly between both groups to really see that difference between those two groups. And this is essentially, Okay, so this is this. So this is basically why random assignment is important. So let's say you want to do a study where you study in a large corporation employees and their health behaviors. And you want to understand whether a wellness program that is done by the HR department has a positive effect on the health behavior. So now you ask every employee, do you want to participate in that wellness program? Who are the ones who are going to participate? Those are those that are by default healthier, or those are those that do have an interest in being healthier. Two different groups. Because the group that does not want to be healthy, that smokes a pack of cigarettes, sits on the couch and eats potato chips, that group will not participate in your wellness program. So you get a confounder, and the confounder is lifestyle. And to get this out of your research interpretation, you basically assign this individual randomly into either group. Either they're part of the wellness program or they're not. Makes sense, right? It's a logical dynamic. It's just it's nice to think that through, because by that, this equal distribution is really the strength of a randomized setting. And this is why randomized studies are the only studies that basically can allow for causal statements. What does that mean? If I know my wellness program improves health behavior, I don't know that until I have not done a randomized study, because only a randomized study will allow to control for those confounding variables and to not measure something that is a self-fulfilling prophecy that basically healthier people will have healthier behavior. Logically, right? Any questions? It's a very important concept. I will come back to you repeatedly. Okay, good, that's this. In the very same context, you have two different main designs. You have a between groups design and you have a within groups design. What's the difference? Between groups design is to compare these two groups, and you say, like, what's the health behavior of that individual after a year in the wellness program? What's the health behavior of that individual after a year in the program? So you use your metrics for health behavior and you compare this between the groups. That's a between groups design. Please memorize that. If you are more interested into a within groups design, it's a little trickier. Because in a within groups design, A, you need more assessments over time, and B, it's also most commonly you have to resort to a correlational design. That means if you only have that group of employees that was randomly assigned to wellness program and you don't have a control, you don't have a between group, you don't have another group to compare them to. But what you can do, you can say, the health behavior of my individuals that went to the wellness program or were very compliant with the wellness program, they had after a year a healthier behavior or a better health behavior, whatever metric you're using. Those that were younger were more likely to have a better health behavior. Those that have ever run a marathon have a better health behavior. Those that eat a lot of vegetables have a better health behavior. So these are the within group design analyses, where you take a group, that's this overarching group of assignment, and you just analyze things within that group, whatever characteristic you're comparing. So that's within groups design. What's also important in this context is data ethics. So there are ethical principles that apply to research of enormous importance, obviously, in research, and the number of examples where ethical principles in research were violated are unfortunately terribly abundant. And that is just something that needs to be avoided at all costs. Therefore, every study that you conduct, including observational studies, needs to go the review of an institutional review board or some kind of quote-unquote ethic commission. And these IRBs, or institutional review boards, basically are being presented with how you're designing your study, how you're collecting the data, how you treat the data, how do you analyze the data, what's your hypothesis, how will you report it? All these things need to go into the ethics. And these ethics are defined by a set of principles that are basically defined in various shapes and form. But basically, there are good clinical practices how to conduct research, which clearly outline how these things are being adhered to. And so there are various stages to that. An institutional review board is basically the overarching kind of control of the study design and the study conduction. And then there's pre-registration, where you go to a governmental institution and you would register your clinical trial there. And then you have, lastly, you have also those that are publishing those data, because all data you want to publish in a scientific journal, you will have an editor-in-chief, you will have a journal editorial board looking at your data, like, hey, well, that really ethically is like, which ethics commission did pass that study? So you go through several stages to have your data transparently shared and discussed and shown to the scientific community to warrant that you're applying to the principles of data ethics. Lastly, we are talking about open science. Open science is a wonderful new trend, basically, which again fosters and emphasizes the need for more collaboration, more transparency, as well as more streamlining of processes. What you essentially do, you share research methodology, you share codes. If you coded something in R, you share your codes. Some journals require that actually to share your codes. You share sometimes even your data, and you're very transparent about what you did, how you did it, and why you did it. So this is basically open science. You increase the level of transparency of the research that you have conducted. And in addition to that, you also allow by that, you allow for recreating findings and replicating the studies that you have conducted. So you allow for replication, which is the most important dynamic and the most important way to corroborate the importance and validity of your research insights based on your study. Any questions? If not, we can use the last 3 minutes to essentially look quickly at the R code. There's 3 minutes left. We're not going to do much. I have the code shared with you. So essentially, if you just open the R code, you can just with Control and Enter, you can run the first lines, and you see again, it creates automatically the data frame. This data frame has the 24 observations that we also seen in Excel. It's the same data as from Excel. It's basically just defining it and presenting it different. Don't run line 7. Actually, hashtag that out. If you want to comment out or you want to inactivate a line, just make a hashtag that will inactivate the line and just leave it as a quote-unquote comment for you. So in case you want to remind your future self, what was that line about? I don't remember this line. I don't remember the function. I don't remember what I wanted to do. If you want to remind yourself, you can do this by hashtag and then just fill out whatever is afterwards. Yes.
How do you, once you get the information inputted onto the top left, how do you get it to for the bottom to change?
Could you repeat that? I'm sorry.
Like once you download like the data, like and it goes on into the top left corner, how do you get it to change for the bottom?
You mean this?
Yeah.
Oh, you just go on 2, you press Control and Enter at the same time. Do you see it now popping up on the right side? Yeah. So that's how you run a line of code. Now just go on 7 and hashtag this out. If you go on line 11, you can do the same thing. You get the variable names and you get here also a little plot. So it basically creates here also a histogram, which we're gonna revisit That takes ages. You can basically do some first analyses. Here you can do summaries, and you can. So with summary, you can get kind of like averages and the data we've done in Excel. But that's it. Thanks so much. Have a good night. Yes. Yeah. How do we connect to so you download the codes. The code is on a module, right? So you download it in a folder. And the only thing you need to do here, you go on File, and you go and Open. Open.
Like mine looks like this. Okay?
Yeah.
So
On File,
file,
Open File.
open file.
Yeah. And now find the downloaded file. It's probably in downloads. I don't know where you downloaded it. You need to download it in the folder on the desktop, I recommend it.
Like from this. Like
No, you get the R code. If you go on Canvas, Canvas. Yeah. There's an R code, the .r file. So no, that's the Excel file. That's the Excel file. R. Yeah. Download that. And now open it in our studio. You can run these things.
okay.
So just go through the recording and play around with it. Then you can actually do exactly the exercises we just did.